So finding more and more that the actual system head is a lot less than what was calculated and given to us for selection.
Yeah, I think you've got to see pump selection as part of a process. And there are various stages at which you size pumps. At tender stage, you're given only a brief amount of information which allows you to determine the pump flow and head, particularly the pump head that you require, because you don't know whose equipment is going to be used. You don't know the pipe diameters. You don't know the pipe lengths. So people are making an estimate just for the purposes of putting a tender in for evaluation. But when you actually come to build a pump, you've got to know that information much more accurately. And it's not a matter of calculation by somebody with a perceived system. You've got to go to the actual system, the actual pressure drops across the machines, the actual size of pipework, the actual size and length of various other features in the system. So once you know what that is going to be for the actual installation, you can get a much more accurate assessment of what the total system resistance will be.
Sure. And what would your comments be on the idea of having margin in the curve?
I'm not a great fan of putting margins on everything. For me, it's a question of putting margins on the things that are likely to change. You don't need a margin on the flow rate. Why would you, if you don't know what flow you want, why do you need a pump? These are the sorts of things where people say, oh, well, I want 50 litres a second, so I'll nominate 60. My question to that is why? In head, you might want to put a margin on because you've got a margin for error on system resistance from friction losses. But you would only keep that at a relatively low level so that you're not building in contingencies that result in problems in the operating point of the pump, because that's the downside of including those contingencies. So my idea is always do your pump selection first, based on the information that you have, and then add a safety factor at the end so that you've got a little bit up your sleeve. And that's usually might be the impeller diameter or the speed of operation, which allows you to get that little bit back if it's not quite there.
Right, so if we do have an accurate selection duty, what would you say the purpose of the VSD would be in that situation?
Well, the purpose of the VSD is is to cover for bad calculation. The VSD is actually there to cater for varying demand. Right. In other words, varying flow rates. But obviously, varying flow rates will result in different system heads. And the VSD allows you to cater for that with no engineering change to the pump. You just control the output of the pump by varying the speed.